Alright children, let's continue solving again the numerical question, MCQ question from this chapter, electric charges, electric field and Gauss theorem. And now we solve question number 11. Now question number 11 says that three charges, one is plus 4q, small q, another is capital Q and small q are placed in a straight line of length L. Straight line of length how much? L at points at distances. One is 0, one is L by 2 and L respectively. The question said that what should be Q? What should be Q means what should be the value of capital Q in order to make the net force on Q to be 0. In order to make the net force on capital small q is what? 0. So for this question, 4 different options are given. One of option A is minus Q, option B is minus 2Q, option C is minus Q by 2 and option D is 4Q. So in order to choose the correct option, okay, so let's do the solution of this question. Now in order to solve this question, let me take a line, straight line whose length is how much? L, small letter L. Okay, so one point is 0, another is L by 2, the midpoint, and another length is what? L, where the three charges are placed. Now one charge is plus 4q charge placed at 0, another charge is capital Q placed at L by 2 length, and another charge is small q placed at L. Okay. Now the question said that what should be the value of capital Q so that the net force of acting on small q charge is 0. So in order to solve this question, we can see that the three charges are in the same line. When the three charges are in the same line, then this charge plus 4q charge exert force on Q and plus q charge also exert force on Q. So the total force, the net force acting by these two charges on Q is 0. So with that we can find the value of capital Q. And question say that as the net force on capital Q, small q is 0, then we use what law? Coulomb's law. So according to Coulomb's law, the force exerted by 4 plus 4q charge on Q plus force exerted by Q, capital Q charge on Q must be 0. Means according to Coulomb's law, force between these two charges is given by 1 by 4 pi epsilon naught. One charge is 4q, another charge is Q, by what is the distance between them? L. From here to L distance L, so it will be L square. Okay, plus force between these two charges, which is given again by 1 by 4 pi epsilon naught. Okay, one charge is capital Q, another charge is Q, and the distance between these two charges is also how much? L by 2. Because this is the midpoint between these two charges. So if this is L by 2, this is also what? L by 2. This way L by 2 with square equals to what? 0, because the net force is 0. Now we can easily solve this part. So let me do the calculation. This is 4q square by 4 pi epsilon naught L square plus capital Q small q by 4 pi epsilon naught. Now this square will open up, so in the denominator it will be L square and 2 square means 4, and this 4 will go in the numerator, equals to 0. So means I can add this quantity now. I cannot add, sorry, but let me just take this quantity to the right hand side. So it will be 4q square equals by 4 pi epsilon naught L square equals to minus q small q 4 by 4 pi epsilon naught L square. So these two cancel out. Okay, 4 also cancel out. 1q and this 1q square will cancel out. So what is remaining? In the left hand side is q minus, and the right hand side is how much? Minus q. So small q equals to minus q means capital Q equals to minus q. So what is the final value? The value of q, capital Q must be equals to minus q. So the correct option is option number A. So you can see the answer is option number A. So capital Q equals to minus q. So this is the correct option of this question number 11. Now we saw the last question, that is question number 12. Now question number 12 says that the electric field required to keep a water drop, the water drop has a mass m, just to remain suspended when charge of one electron is mg. First option is mg, second option is mg by e, third option is emg, and the last option is em by g. Now to choose the correct option, we use the concept of electric field, and electric field is calculated as force per unit charge. Now in order to solve this question number 12, you know electric field is expressed by E equals to force per unit what? Charge. See, electric field is measured as force per unit charge. Now your force on water drop means actually the weight of water droplet, and the weight is given by mass. The mass is given water drop, what mass is m, and definitely the gravity is acceleration to gravity is g. So force is m into g. Now the charge is, what is the charge exerted on the water drop? The one electron, and charge of one electron is E. The charge of one electron E means then your electric field E equals to F by Q. So F means how much? mg by Q means E. So E equals to, capital E equals to mg by E. So the correct answer is E equals to mg by E, small letter E. So that the correct option is option number B. You can see option number B, that is mg by E. So force exerted on an electric field is how much? mg by E. So this is also the explanation and the solution of question number 12. So these are the questions which I have solved, which are important, basically important, okay, for your semester 1 examination. So thank you so much.